So last class, we dealt with just sequences in general, trying to get you used to them. So what we're going to be doing today is we're going to start talking about our arithmetic sequences, and then on Friday we're going to be dealing with our geometric sequences. So down below I have 3 examples of arithmetic sequences. So if we take a look at the first one, what do we do to get from one term to the next? Add 2. Does that work for the whole sequence? Yes, and that's the main thing with your arithmetic sequences. It's always going to be a consistent increase. That one's consistently increasing by a 2. How about if we take a look at our second example? How do we get from one term to the next?
Add 3.
Add 3. Devin's all into this today. So that one also has a consistent increase. But how about for our last one?
Minus 5.
Minus 5 each and every time. So this one's still arithmetic even though it's subtracting. That one is decreasing by the same amount. So since this is a consistent increase, this is why we call it arithmetic. You're always adding or subtracting to get you to your next term. So our change is consistent. Now there was another time in math land when everything was always a consistent change. Does anybody remember when that was? Slope. And slope always dealt with our linear equations. So your arithmetic sequences always goes along with your linear equations because whatever the sequence is increasing or decreasing by, that is like slope. So you could graph it, you'd get this picture of a line on your graph. So our arithmetic sequence is a sequence where the difference between 2 consecutive terms is constant. They like to use the letter D whenever they're dealing with that constant difference between them, which they actually refer to as your common difference. That is our letter D. So in order to find your common difference, what you have to do is you take a term and you subtract the previous term from it. Now you don't always have to do it that way. A lot of times your common difference is easier to see, kind of like our examples up above. So for this first example, our common difference was a 2 because that's what we added to get to each term. Our second example, our common difference was a 3. Our third example, our common difference was a 5. So a lot of times with our arithmetic sequences, it's pretty easy to figure out your common difference. But if you can't see it right away, all you do is you pick a term and you subtract the term before it from it, and that gives you your common difference. So next we have, are the following arithmetic sequences? If so, they then want us to find the common difference. So let's take a look through here. How do I get from a 2 to a 4? Could add 2. How about for 4 to 8? Add 4. And then 8 to 16? Add 8. Is that consistent? No. I did hear somebody say that you could multiply by 2, and isn't it always multiplied by 2? Yeah, but it's not arithmetic because arithmetic means we add to get to the next number every single time. So that one is not arithmetic sequence. So let's take a look at example B. How do we get from one term to the next? I heard somebody say it. Subtract 6. And since it works every single time, you're always subtracting 6 to get you to your next term. Yes, this is an arithmetic sequence. Our common difference would be our negative 6. So then our third one there, our C, we have a negative 3 plus 2i, and then a negative 2 plus 4i, and then a negative 1 plus 6i. Can anybody see the pattern of how you get from one term to the next? Let's look at the numbers. How do I get from a negative 3 to a negative 2? 1. That would be positive. And then 2i to 4i. plus 2i. Is that true for my second term to my third term? Negative 2 to a negative 1, do I add 1?
Yep.
And then 4i to 6i would also be a plus 2i. So is this an arithmetic sequence? Yes. Our common difference would be 1 plus 2i, because that's what is added every single time. So now there's a whole bunch of different kinds of questions that they will ask you regarding your sequences. So I'm going to try to get to every kind of question in our notes today before you do your homework. So example number 1, they want to know, how would you go about finding your 20th term? So based on what we know right now, we would start with our sequence that we're given, our 5, 8, 11, and 14. What are we always increasing by? 3. So there's our first four terms. We want to find the 20th term. And we would keep going all the way to 20, but does that look like fun? No. So what somebody did a long time ago is they made our lives a little easier, and they came up with a formula for us. So it starts with a sub n. And it's going to equal a sub 1 plus n minus 1 times your d. So let's kind of go through this formula a little bit. A sub n, who remembers from last class, what does that represent? Not x. That's the term we're looking for. Our a sub 1 is what? First term. Our n is what? Term number, or sometimes it's referred to as your position, which means where are you in the sequence, which is the same as your term number. And then the d, as we just learned up above, is our what? That's our common difference. So using that formula now, let's go back up and find our 20th term. So we know our first term is a 5. I'll make a little list of what we know. We figured out that our common difference was a 3, because it took 3 to get to the next term. We're looking for our 20th term, so we're going to use that n equals 20. So using that formula, a sub 20, I'm going to plug 20 in for my n, equals our first term plus n minus 1, so 20 minus 1, times our common difference, which I'm going to tell you, always put your d in parentheses. Our next example will be exactly why you want to do that. So then you can just type that in your calculator. 5 plus 20 minus 1 times 3. I got one person telling me 62. Do we agree? All right. So our 20th term is 62. It's a lot faster than putting our little lines out there to get to 20 and keep adding until we're at our 20th term. Let's do a quick little definition. What kind of a formula was this? Explicit or recursive? This one was an explicit. Usually what throws people's off is that n minus 1. You think it's going to be recursive, but did I have to know my 19th term to find my 20th term? No, so that's why it's explicit. I could find just the 20th term. Okay, so let's take a look at example 2. We're finding the 68th term in the sequence of 16, 7, negative 2. So let's write what we know. We know our first term is a 16. What would be our common difference here? Negative 9. And which term are we looking for? 68. So our n is going to be a 68. So now we can plug it into our formula that we were just given. This is going to be a sub 68 equals 16 plus 68 minus 1 times negative 9. And again, make sure you put your common difference in parentheses, because when it's negative like that and you don't put parentheses, so many people just subtract 9 afterwards because you forget it's actually being multiplied. So you got to put your parentheses around that one. So go ahead, type that in your calculator. Let's see what we get for our 68th term. I got negative 587. Does anybody disagree? All right. So our 68th term is negative 587. So example 3, same thing, it's just they list it out for you. Our first term is 2. So a sub 1 is a 2. They tell us our common difference is 3. So my D equals 3. We're trying to find our 16th term. So n equals 16. So again, let's plug that into our formula. So a sub 16 equals 2 plus 16 minus 1 times 3. You think you got it, Paul? What'd you get? 47. Does anybody disagree? All right, sounds like 47 wins. I think so. So let's take a look at example 4. We have write a formula in explicit form that could be used to find any term in the pattern 2, 5, 8, and 11. So again, let's make our little list of what we know. Our first term is what? 2. Our common difference? 3. Do we know which term we're looking for? No. So n is going to stay as n for now because they want us just to write a general formula. So a sub n equals 2 plus n minus 1 times 3. So that's an explicit form that could be used to find any term. We would just have to then plug in for our n. However, generally on the Regents exam, you won't see that as your multiple choice answer. They want you to kind of clean it up a little bit. Meaning, we would have to distribute our 3. So we would have 2 plus 3n minus 3. And then combine our like terms. So we'd have 3n minus 1. So both of these forms up here are explicit forms that would work. You just never know which one you're going to see. So then part B wants us to write a recursive formula that can be used to find the nth term. So with our recursive formulas, we always have to write what our first term is. So I'll put that first. Our a sub 1 equals a 2. And then we have to remind ourselves, what are we doing to get from one number to the next? Adding 3. So for our recursive, we have to use our previous term notation, which would be our a sub n minus 1. So we're taking our previous term and adding 3. That's if we're writing it as a function. So that would be our recursive formula there for our sequence. So example 5, which term of the arithmetic sequence of 15, 13, and 11 will be negative 13? So this one's asking a little bit different of a question. What are we actually looking for? We're trying to find our n. They asked us which term, which means we don't know our n. We're trying to figure out what position in that sequence negative 13 will be. So we know our first term is 15. What's our common difference? Not 2, negative 2. The other part that we know this time is our a sub n is negative 13. We know what the actual term is. We're just trying to find what number in that spot is it. So still using that formula, yep. Instead of a sub n equals, we're going to put negative 13 equals. And then it's our first term plus n minus 1 times our negative 2. So still that same formula, we just have different stuff we're plugging in this time. So then to try to solve for n, we would distribute our negative 2 first. So that would give me 15 minus 2n plus 2. Combine our 15 and our 2, and what do we get? 17. So we got negative 13 equals 17 minus 2n. So what do we want to do next? Subtract the 17. So negative 13 minus 17. Divide by negative 2. That equals 15. So negative 13 is the 15th term. So again, lots of different ways we can use that formula there. So as I was mentioning before, if you were to take an arithmetic sequence and actually graph it, your graph would look like a line. So you could write the equation in mx plus b form. If we took a look up there again at that first one on the top on this page here, that one does look like mx plus b form. It's just it's using an n instead of x. And the common difference is the same as your slope. So sometimes what we have to do is we use our slope formula to help us find our common difference if we need to. So the formula for an arithmetic series is just this equation of a line. So there's a couple ways we can do this here. We can do it using our formula on the front. Our a sub n equals a sub 1 plus n minus 1 times your d. Or you can think of it as your mx plus b, but instead of, your y and your x, we're using a sub n and n. So we'll go through both ways, see what you guys think. So some people still like taking their little sequence there and writing it as a table. If you want to, go right ahead. There's nothing saying you have to, though. So if we're using our formula for the front, Our first term is a what? 3. So my a sub 1 is a 3. We don't know our n, so that's going to stay as n. But our common difference, what am I adding each time? 2. So then we would just have to clean it up by distributing our 2. So that would give us a 2n minus 2. So we would get a sub n equals 2n plus 1. So if we did it the other way, using our mx plus b, again, you could look at your table. Our slope is 2 over 1. Change in y over change in x. Y changes by 2 as x changes by 1, so our slope would still be 2. And then for your b value, you would just continue your pattern until you get to where x is 0. So if I was going backwards, what should this number up here be? 1. So as you can see, gets you the same answer in the long run.
Are we going to need to know the second test?
Possibly. Because there are some examples that we're going to do that it's easier if you do it as mx plus b as opposed to the other formula. And we'll get to those on the next page. So let's take a look at this little word problem here. We have each day Susie waters her plants from the water in a rain barrel. On day 1, her barrel had 45 gallons of water. On day 6, it had 30 gallons of water. Write an explicit rule to find the amount of water in the barrel on the nth day. So here, we would have the 2 points, 145, because on day 1 you had 45 gallons of water, and then 630, because on day 6 you had 30 gallons. So this is one of the ones where it's set up where it's going to be easier to do your slope formula. y2 minus y1, if you guys remember your slope formula, over x2 minus x1 so 30 minus 45, yep. 6 minus 1 gives us a 5. So what does that reduce to? Negative 3. Does it make sense that our slope's negative? Yeah, because we go from 45 gallons down to 30. So it makes sense because it should be going down. So we have the first part of our rule. A sub n equals negative 3n. We just need to find our b value. So if our slope this way is going down by negative 3, to go up the other way to get me to where x is 0, which is our b value, got to add 3. So what would 0 what? 48. So then plus 48. And there's our rule for that one. So for these examples here, before I came to class to actually teach this, I made my answer key, and then the 2 other teachers who teach Math 11 did their answer keys. And we figured out there's actually 4 different ways you can do all of these problems. And it was quite interesting because each of us all did them in a different way. So instead of teaching you all 4 different ways, I'm going to teach you what I think are the easiest 2 ways. And then you can pick whichever way you like best. One of them was just way over there. I don't think you guys are going to get that one at all. So example 7, we're trying to find the 20th term Which two terms do we know?
Fourth and the 7th.
4th and the 7th. So whenever we are dealing with our arithmetic sequence, we always need to know our common difference. That's always like the first thing you should look for. So just kind of like that last problem and the last couple of problems I was talking about, your common difference when you don't have consecutive terms is your slope formula. So my term 7 minus my term 4 over 7 minus 4. Because we're skipping them, you got to put it over the 7 minus 4. So 24 minus 12, what does that give us? 12, 7 minus 4 gives us 3. So our common difference is a 4. So now if we think back to our formula that I gave you on the first page, why does that formula not really work right now? Huh? We don't know what the first term is. So that's a lot of work to find our first term and then our 20th term. So one way we could go about it is if you kind of set up your table here, you could keep going all the way to the 20th term. Or we could find our first term from this table, couldn't we? So if going down the table is plus 4, what would going up the table be? Minus 4. So our third term would be 8. My second term would be 4. My first term would be 0. So then you could use your first term of 0 and figure it out. If you wanted to go further like we were doing on our last problem and use your mx plus b form, you could go to when x is 0 and get your formula that way. So to find my 20th term, I'm going to go ahead and still use this formula. We now know our first term is a 0. We're looking for an n of 20, common difference of 3. So let's see what we get. Ah, good. You guys are paying attention. Or at least Paul is. I heard a 76 question mark. Somebody else got a 76? That's good, because you should get 76. All right, example 8, we got the 5th, 6th, and 7th terms in a sequence are 20, 21 and a half, and 23. What is the first term? So again, another way for us just to work through this is first term, second, third, fourth, 5th is 20, 6th is 21 and a half, 7th is 23. What's our common difference to get from the 5th to the 6th and then the 6th to the 7th? 1.5. So again, to go up the sequence is add 1.5. To go backwards would be what? So we're going to subtract 20 minus 1.5. 18.5. Minus 1.5 again. 17. Minus 1.5 again. And minus 1.5 last time. 14. So our first term is a 14. So they want us to calculate a sub 8, given that a sub 5 is 41, a sub 11 is 17. So again, we can look at just our 5th term, 6th, 7th, 8th, 9th, 10th, 11th. Now you put a little dot, dot, dot showing we know our sequence continues, but we're looking at just this portion of the sequence. So again, we got to figure out what is our common difference. So how would we figure that out? Slope. So my 11th term minus my 5th term over 11 minus 5, their positions subtracted. So 17 minus 41 gives us negative 24 over 6. So we should get a negative 4. All right, so let's start at term 5 and subtract 4. 41 minus 4. 37. 37 minus 4, 33. And then minus 4 again, 29. So a sub 8 equals 29. Our 8th term is 29. So now, the people who write your Regents exam, they can't be nice and always just give you numbers. They sometimes give you ones that have letters. So we have algebraic expressions as your pattern. So like here we have the pattern of x plus 3 is your first term, 2x plus 5 is your second term, 3x plus 7 is our third term. So they want to know what is the common difference. So this goes back to what I talked about on the first page. It's not as quick and easy to see your common difference. So take one of your terms. So in this case, I'll take my second term. Subtract the term before it. So I'm going to subtract my first term from it. So 2x minus x gives me an x. 5 minus a 3 gives me a 2. So our common difference would be x plus 2. So then I always kind of go back and check. Well, if I take my second term, if I add an x to my 2x, do I get 3x? Yes. And if I add 2 to 5, do I get 7? Yeah. So we did it correctly. We got the right common difference. They want us to write an explicit rule to find the nth term. Okay, we know our common difference is x plus 2. We just found it. What's our first term? X plus 3. So I'm going to use that rule from the front on the first page that I gave you. So a sub n equals my first term plus n minus 1 times my difference of x plus 2. Now you could multiply it all out with your x plus 2 times your n minus 1. You don't have to, though. You can leave your answer just like that. So now down here, I want you to find your 7th term. Plug in your 7 for your n. Let's have you find your 7th term for that. Yeah, so your 7th term should be 7x plus 15 once you combine all your like terms. All right, one more thing on the back. Our arithmetic means. Arithmetic means are the terms between any two non-consecutive terms. So for example, if we look at number 10, we got 3 spaces here. So we have 3 arithmetic means in this problem. If I had 5 spaces there, I would have 5 arithmetic means that I'm looking for. If I 10 spaces there, how many arithmetic means would I have? 10. So that all the arithmetic means is that's how many spaces you have between those numbers. So, like we were doing on the last page, we have to find our common difference. So I'm labeling those as my terms, term 1, 2, 3, 4, and 5. I know term 1 and term 5, so I'm going to use those to find my common difference by doing the slope formula again. So 110 minus 86, term 5 minus term 1, over 5 minus 1. So what do we get? 6. Common difference is 6. So now I just got to find those empty spaces. So 86 plus 6 gives us 92. Plus 6 gives us 98. Plus 6 gives us, and then I always just check, is 104 plus 6 110? Yes. So that's how we know it did correctly. It's always plus 6. So 11, form an arithmetic sequence that has 5 arithmetic means between negative 11 and 19. So how many spaces am I going to put between negative 11 and 19? 5. So negative 11. 1, 2, 3, 4, 5. 5 arithmetic means 5 spaces. So again, I'm going to label these. This is my first term, second, third, fourth, fifth, sixth, seventh term. So now let's go find our common difference, again, using our slope formula. So 19 minus negative 11 over 7 minus 1. So what does our common difference end up being? 5. So let's start adding. Negative 11 plus 5 is negative 6. Plus 5 is negative 1. Plus 5 is plus 5. Plus 5, 14. And then again, just to check, 14 plus 5 gives us our 19, so we did it correctly. All right, and then our last one here. You have to remember what these notations mean. A sub n minus 1 means that's our previous term. The one we haven't dealt much with is your a sub n plus 1. What term does this refer to? Your next term. So that means I have the previous term, I don't know that middle term, and I have my next term. So basically we're just looking for what would come in between our 12 and our 18. So again, same thing. Let's do our slope formula. 18 minus 12 would be over 3 minus 1, because I would have my third term and my first term. So D equals 3. So 12 plus 3 gives us 15. Again, just to check, plus 3 does give me 18. So my arithmetic mean that they're looking for is my 15, that number right there in the middle.